Hello everyone, welcome to Mathworld. This video is to discuss Cambridge International AS and A-Level Mathematics Paper 3, which is a pure mathematics 3 for February-March 2024, and the code is 9709/32. So let's move on to question number 1. So for question number 1, find the quotient and remainder when this quadratic polynomial or this quadratic function is divided by x squared plus 5. So in order to get the quotient and remainder, the easiest way is to apply the polynomial division. Okay, so now I will perform the polynomial division. So x degree 4 minus 3x cubed plus 9x squared minus 12x plus 27 is divided by x squared plus 5. So now we need to think of a term so that the term multiplied with x squared to get x degree 4. So obviously that term is x squared. So x squared times x squared to get x degree 4. X squared times plus 5, it will be plus 5x squared. Okay, then we just subtract the terms. So x degree 4 minus x degree 4, you'll be getting 0. Then the second term is minus 3x cubed. You minus 0, just need to rewrite the term. Then 9x squared minus 5x squared, that is plus 4x squared. And bring down negative 12x. So to get negative 3x cubed from x squared means that we need to multiply with negative 3x. So this is going to be negative 3x cubed. So minus 3x times 5 is minus 15x. Again, now we subtract. So bring down the 4x squared. Minus 12x minus 15x is basically minus 12 plus 15. That is plus 3x. And now bring down plus 27. Now, lastly, to get 4x squared from x squared, we need to multiply with plus 4. Then you will be getting 4x squared plus 20. Okay, 4 times 5 is 20. And then subtract it. Then you will be getting 3x. 27 minus 20 is plus 7. Now, when you look at here, the degree of the x at this moment is 1, and the degree of the x in the divisor is 2. So as long as the degree of the x in this expression is less than the degree of x in the divisor, that means we need to stop this polynomial division. So which means our quotient, okay, will be this quadratic function, which is x squared minus 3x plus 4, and the remainder is the linear function. So that is 3x plus 7. Okay, so done for this question number 1. Okay, so for question number 2a, find the coefficient for x squared in this expansion. Now, 2x minus 5 multiplied with square root of 4 minus x. So I will rewrite my square root of 4 minus x. Okay, so for the 2x minus 5, because this is degree 1, that means I'm not going to expand it, but we will be expanding the second term, which is 4 minus x degree half. Now, for your information, because the degree is half, which is not the positive integer, that means we need to use the binomial expansion in paper 3, which is 1 plus x degree n. Okay, this is the formula, which is 1 plus nx. Now, here we need to get x squared. So the next term is n times n minus 1 over 2 factorial x squared, and so on. Okay, so that means now I need to get 1 and followed by plus in order to use this formula, which means instead of 4 minus x to degree half, I need to factorize the 4 because I need to make it to 1 here first. That is a restriction for using this formula, which means now I factorize 4 to get 1, then minus. So when you factorize 4 from x, that is x over 4, and with degree half. Okay, and then now bring in the degree. So the degree half will be bring into the whole bracket, which means now here I will be getting 2x minus 5, then 4 to power half, After that, now the next term is 1 minus x degree x over 4. But remember, our condition to use this formula is here must be plus. So which means I will rewrite it will be 1 plus negative x over 4. Then degree half. Okay, so now the 4 power half is basically square root 4. Though this square root 4 can be taken out and changed to 2. So I will direct change to 2. It will be multiplied with 2x minus 5 and followed by the expansion. Okay, so just use this binomial expansion formula to do the expansion up to x squared. Now I will be getting 1 plus, now my n is half, so n, my x becomes negative x over 4. Then followed by n minus 1 over 2 factorial. So half minus 1 is basically negative half. Then over 2 factorial. Then my new x is negative x over 4 and squared. Okay, so then from here, I will just rewrite the first two terms and simplify the terms inside the square bracket. So it will be 1 minus x over 8, then minus 1 over 128 x squared. Alright, so now when you look at the question, we are interested to get the coefficient for x squared. That means now, when you look at the 2x, okay, this 2x, I need to multiply with x over negative x over 8 in order to get the x squared. Okay, and also for the negative 5 here, I multiply with negative 1 over 128 x squared. That will be my term of x squared. So now the next step is I just write coefficient of x squared. I will not do the expansion to get the terms. So don't forget there is a 2 in front. So multiply with this 2x multiply with negative x over 8 and ignore the x squared. That will be 2 times negative 1 over 8 followed by the minus 5 times by negative 1 over 128. These are the coefficients of x squared. So you will get 2 times negative 27 over 128. Okay, so at last, this is going to be negative 27 over 64. So this is the coefficient of x squared in this expansion. Okay, now next question, B. State the set of values of x for which the expansion in A is valid. Now, for your information, our general expansion, which is 1 plus x degree n equals to all these terms, is valid when modulus of x less than 1. So where do I get this modulus x? It's actually modulus of this term, right? Or absolute of that term. So which means now we will have to refer back to this expansion, this term, and I will take modulus of negative x over 4 and let it be less than 1. Then your expansion will be valid. Okay, so here I will just write modulus negative x over 4 less than 1. Okay, therefore, now after modulus, the negative becomes positive. So this is basically 1 over 4 modulus x less than 1. Therefore, your modulus x less than 4. So this will be the sets of x values for which the expansion is valid. Okay, now next question number 3. It is given that the z is negative root 3 plus I. A express z squared in the form REI data, where r is greater than 0 and theta is between minus pi and pi, but inclusive pi. So from the z, okay, or from the z, right? From the z or from the z. So from here, I will write down the modulus first. So modulus, now if let's say your complex number is a plus bi. So the modulus is basically square root of a squared plus b squared. Okay, then from here I will be getting square root of negative root 3 squared plus 1 squared because it is 1i. So from here you will be getting square root 4 and at last this is 2. Now for the argument we need to draw the Argand diagram. So now your x or real parts is negative root 3. Imaginary parts is 1 because it's 1i, positive. So this is my complex number. Now our data, our argument is counted from the positive x-axis. This is our imaginary axis. Okay, and here is the real axis. Now from here, I will say that our argument z equals to, for your information, here I can form a right angle triangle. So I know that this is 1 unit and the horizontal distance is square root 3 units. So I may find this angle using inverse tangent, okay, because you are given the opposite and adjacent sides. So which means now here, your argument z is basically pi minus inverse tangent of the vertical distance 1 over the horizontal distance is square root 3. Okay, then from here, you will be getting pi minus pi over 6, which is 5 over 6 pi. Okay, and now the question asking for z squared in terms of REI data. So from here, right, so for z squared, that means now your R is modulus of z squared, or square of modulus z is the same. That means this is going to be 2 squared to get 4. Okay, then the theta, which is here, theta in the question, that is argument of z squared, that is also 2 argument z. Okay, so it will be 2 times 5 over 6 pi. And then from here, I will be getting 5 over 3 pi. But now look at the interval. The interval is between minus pi and pi. Maximum is pi. But now here I'm getting 5 over 3 pi, which means 5 over 3 pi, okay, this is 1 pi. So 5 over 3 pi is in the 4th quadrant. This is my 5 over 3 pi. Okay, so therefore, we need to calculate from the negative part. That means here is going to be 1 over 3 pi because one circle is 2 pi units. So I have to write my theta as negative 1 over 3 pi. Okay, so after you found this, that means we can write our R square in REI data form. So our R now is 4. I negative 1 over 3 pi. Or I can just rearrange 4e negative 1 over 3 pi I. So that is the solution of the first part. Okay, now for B, the complex number W is such that z squared W is real. Right, real means no imaginary part. And the modulus equals to equals to 12. Find the 2 possible values of W, giving your answers in the form REI alpha, where R is greater than 0 and alpha again is between minus pi and pi. Okay, so now since you need to find omega or W, okay, in this form, so I will just let W be REI alpha. Okay, and now from this statement, z squared W is real. So I will say z squared W is real. That means, right, when I draw the Argand diagram, it will be this left side or right side. Okay, as long as no imaginary part. So this is my real, and this is my imaginary axis. So either this side, which is on the right side, or on the left side. Okay, so which means the argument for the z squared W equals to 0, because if this is your argument, this is the vector, so argument is 0. But if it is on the right side, left hand side, okay, this is a vector, then your argument is going to be pi. Okay, so here I will write, or argument z squared omega or W is pi. So we have 2 answers. Now, from the previous part, when you have argument z squared from here, okay, it will be 2 of argument z. How to get it? It's actually argument z plus argument z because of the multiplication. So use this concept. So which means here I will be getting argument z squared plus argument w equals to 0. Okay, so now from here, when you look at this, you express w in REI alpha form. That means the alpha is the argument of w. So it means that argument w equals to alpha. Okay, so from here I will say, therefore, alpha, okay, so when you look at here, this can be moved to the other side. Okay, so it will be negative argument z squared. And the argument z squared already found just now. Argument z squared is negative pi over 3. Okay, so from here I will just write negative of negative pi over 3. So I will be getting pi over 3. Okay, now for the second case, whereby the argument is pi. So from here, again, use the same method. Argument z squared plus argument w or argument omega equals to pi. So now, argument omega equals to pi minus argument z squared. Okay, so it will be alpha equals to pi minus argument z squared from the previous part, negative pi over 3. Then pi minus minus is plus. So pi plus pi over 3, that is 4 over 3 pi. Now again, our alpha maximum is pi by referring to this interval. Okay, so now here I need to draw the angle. Alright. So 4 over 3 pi is basically here. This is my 4 over 3 pi. So it is exceeding pi, therefore I have to consider negative part. I mean negative value. So the negative value for this is going to be 2 over 3 pi. That means this is same as negative 2 over 3 pi. Okay, so once we have found this argument, which is the alpha, then now we need to find the r. So the r is found using this modulus. So now modulus z squared over omega is 12. So that means here I can change to modulus z squared over modulus omega is 12. And I need to find out what is my omega, right? So this modulus omega or modulus w move up. So this one move up, the 12 move down, which means my modulus w equals to 12 over modulus z squared. Okay, then from here, I will say my r equals to modulus w equals to 12 over modulus z squared. You get it from previous part, which is 4. Then over 4, that is 3. So from here, my w or omega equals to 3e pi over 3I. Another one is 3e, and the alpha is negative value. So negative 2 over 3 pi I. So this will be the solution of this question. Okay, now next question, the positive numbers p and q are such that ln p over q equals to a and ln q squared p is b. Given two ln values, express ln p power 7 q in terms of a and b. Okay, so from here, I will start with ln p over q equals to a. Now, according to the properties of log or ln a minus ln b, that is ln a over b. Okay, and same goes to ln a plus ln b, that is ln ab. Then from here, I will be getting ln p minus ln q equals to a as a first equation. And from the second ln, the second expression, ln q squared p equals to b, that means now refer to the second formula, that is ln q squared plus ln p equals to b. And then we have another formula here, which is a ln b equals to ln b to the power of a. That means now the squared, the power 2 can be brought down. Then I will just get 2 ln q plus ln p equals to b. These are my two equations. Okay. Now, to get this ln p power 7q, I need to find out what is my ln p and ln q so that I can just apply this summation later on. Okay, so means that now I am going to solve the simultaneous equations. So now I notice that the ln p are the same, exactly the same, plus ln p from first and second equation. Therefore, I'm going to use the elimination method to find the q. Okay, ln q. So it means that I will use second equation minus first equation because both also positive ln p. So now second minus first, 2 ln q minus ln q. That means that is going to be 3 ln q. Then right hand side, it will be b minus a. Then from here, I'm getting my ln q as 1 over 3 times b minus a. Okay, so after you found the ln q, then you can just find ln p, either from first or second equation. I will be referring to first equation. So my ln p is basically a plus ln q. Then this is a plus 1 over 3 b minus a. So to simplify this, I will just do the expansion. Look at here. This a minus 1 over 3a. That means that is 2 over 3a. So I will get 2 over 3a and then 1 over 3b. Okay, and then this is a plus. So then plus 1 over 3b. Okay, then now from here, I will refer to this term ln p power 7q right now. So ln p power 7q is going to be ln p power 7 plus ln q. Then this is same as 7 ln p plus ln q. So 7 ln p replaced by these two terms, 2 over 3a plus 1 over 3b. Plus, now ln q is going to be 1 over 3 of b minus a. So 1 over 3 of b minus a. So from here, I notice that all are divided by 3. Okay, means that I can factorize 1 over 3 from all the terms. Once I factorize, then I will do expansion. So 7 times 2, you get 14a. Then 7 times plus b, that is plus 7b. Then for the next term, once you have factorized the 1 over 3, just left the bracket. Means that this is plus b minus a. So from here, I will be getting 1 over 3. So 14a minus 1a, that is 13a. 7b plus 1b, that is 8b. So this is our ln of p degree 7q. Okay, so for question number 5, on a sketch of an Argand diagram, shade the region whose points represent complex numbers z satisfying the inequalities modulus of z minus 4 minus 2i less equals to 3 and modulus of z greater equals to 10 minus modulus of 10 minus z. Okay, so from here, modulus of z minus 4 minus 2i less equals to 3. Now, when you compare with the general form of a circle, so basically a circle, okay, with center AB and radius R, that is modulus z minus a plus bi equals to R. Okay, that will be the circumference of the circle. Right, so now here I will change to that form, which is z modulus z minus bracket 4 plus 2i, then less equals to 3. So from here I will identify the center. So the center of the circle is basically 4, 2. Okay, and then the radius is 3. Now if it is equal sign means that is the circumference of the circle, but then this is less and equals to 3. That means the points will be the whole circle, inside the circles, and also on the circumference of the circle. So for the second inequality, which is modulus of z greater equals to modulus 10 minus z, alright. So now here I will change to the perpendicular bisector. So perpendicular bisector, alright, that is modulus z minus a plus bi equals to modulus z minus c plus di. So then you will be getting the perpendicular bisector. So now I have to find out the points first. The points means the AB and the CD. So which means the first one will be z minus 0 plus 0i greater equals to, okay, now here I can factorize a negative. So factorize negative, then z minus 10. Then from here, modulus of negative is actually positive. So I will get modulus z minus, okay, instead of z minus 10, I will write greater equals to z minus 10 plus 0i. Then I know that my points will have coordinates of 10, 0. Okay, when this inequality change to equal sign, which is the equation, I will be getting the perpendicular bisector passing through 2 points. So from here, I need to sketch the center for 2. Okay, so now let's say this is the imaginary axis and this is the real axis. Okay, so my point with coordinates 10, 0, so means that here probably 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, then for 2, so 1, 2, 3, 4, 5, 6. Okay, now I will mark the circle first, center for 2. So for 2 is here. Radius is 3. Radius is 3 means that 3 units up, down, left, right. So 3 plus 2 is basically 5. Okay, then 3 units down. So means that here is already 2 units. So it will be passing through this or touches this point, minus 4 minus 1. Okay, then after that 3 units to the right side. And then 3 units to the left. Excuse me. Now here we can draw the circle. Okay, so let's say this is a circle. Then now I will just label this circumference as modulus of z minus 4 minus 2i equals to 3. And now this is less equals to, that means it will be including the points inside the circle as well. And then now the next step is to draw another inequality. So from the second inequality, I will get 2 points. First point with coordinates 0, 0. And then the second point with coordinates 10, 0. Okay, so 0, 0, 10, 0. Now I need to get the perpendicular bisector. So obviously the midpoint is at 5. Okay, so since this is perpendicular, that means it should be a straight line, which is the vertical line parallel to the imaginary axis. And then now from here, look at this inequality. This means the distance from the general point to origin is at least or is greater than or equals to the distance from the general points to tan 0. So now you have two choices. Either you choose here, okay, as the z. So when I choose this, means that now when I consider the points, okay, the distance. So look at this distance. Distance from the general points to origin obviously is less than distance from the point, okay, from this point to tan 0. So I need more, which means my points will not be on this side. So it will be on this side, okay, because we only have two sides, either left or right. So obviously the points is on the right hand side. So it means that now I have to erase this. So therefore, I know that my region is going to be inside and on the right side of the circle. Okay, so then if you want to label, this orange line is basically modulus z equals to 10 minus modulus 10 minus z. Okay, so when equal sign, we use a straight line. I mean, we use a solid line. If there is no equal sign, then you have to use a dotted line. So that's all for this part. Now next part, find the greatest value of argument z for the points in this region. So now your region is the shaded region, which is a red color, and then the greatest argument is basically calculated from the origin. Okay, which means now my greatest argument will be this point. Okay, so this is my greatest argument. And now I need to find out what is this argument z. So argument z, since this is right angle triangle, then I can just find out what is the height here, okay, over the horizontal axis, right, the adjacent side. So now, since this is just sketching, you cannot just read. What to do is, I know that this is going to be, okay, I know that here is 1 unit because 4 and 5. And then since this dot is a center, okay, this is a center. And then we know that in the triangle, in the circle, it is with radius 3. So which means from this point, from the center to any points on the circumference, it will be 3 units. So which means here is 3 units. Okay, then I can find out what is my height here. So as long as I know my height, and then this is same as 2, here is 2 units, then I know that my vertical axis or my opposite side of the argument z is h plus 2. Okay, then my horizontal axis or my adjacent side is 5. Right, so here I will just draw the triangle. This is 4, 2. This is the center, 4, 2. Okay, then this is h. And the horizontal distance is 1 because 4 to 5. So here is 1 unit. So then from here, right, I need to find out what is my h. So according to the Pythagoras theorem, the h is square root of 3 squared minus 1 squared. That is square root 8. So square root 8 is basically 4 times 2. Right, square root of 4 times 2, then you get 2 square root 2. So I know that my h is basically 2 square root 2. And now I refer to the big triangle. This is my argument z. Here is 90 degrees. Then the height is h plus 2 because the distance is actually 2 units from the rear axis. So that means here is 2 plus root 2. And then the horizontal distance is basically 5. Okay, here is 5. Right, so here is 5. Now I need to find the argument. So I will write greatest argument equals to inverse tangent of 2 plus root 2 over 5. So then when you calculate this value in radians, that is going to be 0.768. So that is the greatest argument. Okay. So next question, number 6. The equation of a curve is 2y squared plus 3xy plus x equals to x squared. So show this dy dx. So now I will rewrite the question first. 2y squared plus 3xy plus x equals to x squared. Now I can just direct differentiate the function of y using the implicit differentiation. So differentiate fy means that f is a function of y with respect to x, that is d over dy fy. So you differentiate the function of y with respect to y, then you times by dy over dx, which means now the 2y squared you differentiate with respect to y, that is going to be 4y. Then you multiply with dy over dx. Okay, plus the next one is 3xy. So 3xy, I will treat this as two terms, u and v. That is the products rule. So when products rule, differentiate uv, whereby u and v are functions of x, that is uv prime plus vu prime. Okay, so from here, I will say my u is 3x, therefore differentiate 3x is, I keep the 3x, then differentiate y with respect to x, that is 1, because you differentiate y with respect to y first, that is 1, then you times by dy over dx. After that, you plus, keep the y, which is our v, differentiate 3x with respect to x, that is 3. And now, next term is plus x. So when you differentiate plus x with respect to x, that is 1. Then followed by the right side, x squared becomes 2x. Okay, now I need to get dy dx as a subject. Therefore, I will group the first two terms. And at the same time, I will factorize the dy dx. So my dy dx, once you factorize the dy dx, that means you still have 4y plus 3x. So for right hand side, you need to move these two terms to the other side. That will be 2x minus 3y minus 1. Okay, so now when you check here, the denominator is 4y plus 3x. So it means that I can just move down the bracket. Therefore, my dy over dx is going to be 2x minus 3y minus 1 over 4y plus 3x. So we have shown this differentiation. Okay, next question. Hence, show that the curve does not have a tangent that is parallel to the x-axis. So whenever you see tangent, that is dy over dx. Okay, when it is parallel to x-axis, let's say for example, this is your graph. Right, so the gradient, the tangent line parallel to x-axis is this red line. So that means dy dx equals to 0. Okay, when it is parallel to x-axis, but then you need to show that does not have. So even though it shows does not have, I will just let it be dy dx be 0 first, but I just need to show that there's no solution when I let dy dx be 0. Okay, so I will write here, when the tangent is parallel to the x-axis, dy dx equals to 0. Okay, so now I will rewrite my dy dx from the previous part. Just copy this expression. So which means now my dy dx equals to 2x minus 3y minus 1 over 4y plus 3x. So when dy dx equals to 0 means that this is equal to 0. So 0 equals to 2x minus 3y minus 1 over 4y plus 3x. Now, from here, okay, I will just, when it is 0, means that I will just move up. The denominator is still left side, I mean the numerator equals to 0, which means now here I get 2x minus 3y minus 1 equals to 0. And then from here, probably I can just get 3y equals to 2x minus 1. Let this be the first equation. And now, it shows that the curve does not have tangent that is parallel to x-axis. For your information, this straight line, this red line is a tangent. Okay, so this tangent line, it is also, if there is tangent line, it will be intersecting the curve at one point. So you want to show that there is no intersection between the tangent line and the curve. Okay, so now I have to show that there is no intersection. So now for the curve equation, I will rewrite. Just copy back this curve equation. Then I will write here 2y squared plus 3xy plus x equals to x squared. Let this be the second equation. Now I substitute first into second when you need to solve the simultaneous equation. Okay, so first of all, my 2y squared, I need y. But here, for the first equation, I got 3y. So which means I can further change. Okay, I get the y as a subject. So my y is basically 2x minus 1 over 3. This is my first equation. So I will be getting 2 times 2x minus 1 over 3 squared. Then plus 3xy. Okay, so for this 3xy, I will group the 3 together with the y. That means it will be 2x minus 1. Okay, so I just need to times x by 2x minus 1. That is my 3xy. Then plus x, after that equals to x squared. The equals to x squared will be moved to left side because negative x squared, that equals to 0. Then now, for this equation, I can just do expansion. Now remember, when you do expansion, there's a squared here. This squared can be brought into the numerator and denominator. So when you consider the squared in the denominator, that is 3 squared, which is 9 in the denominator. Then I will combine that with the 2, which means I will be getting 2 over 9. And then squared of 2x minus 1. So for square of 2x minus 1, you can just easily expand it using the quadratic expansion, which is a squared plus 2ab plus b squared. Okay, then you will be getting 4x squared minus 4x plus 1. Then for the next term, just do expansion. That will be 2x squared minus x. And then copy the other two terms. Okay, so from here, before I simplify, I will say that the minus x and plus x will be cancelled off. And then since there is a 2 over 9, the over 9 in the first term, I can just times 9 to the whole equation to eliminate the fraction. So which means after I times 9, I still have the 2. So this 2 will be brought into the whole bracket, which means I will be getting 8x squared minus 8x plus 2, and then followed by the other two terms, which are plus 2x squared minus x squared equals to 0. Okay, so from here, because I times 9, mistake here. I times 9, that means this 9 must times to these two terms. Okay, so basically, before I times, I will say that the x squared, 2x squared and minus x squared, these two terms, it can be just simplified into 1x squared. So the 1x squared times 9, it will be plus 9x squared. So that will be my simpler form. Okay, now simplify the first and last term. 8x squared plus 9x squared, basically 17x squared. Then minus 8x plus 2 equals to 0. Now, when you refer back to the question, we need to show that the curve does not have tangent, means that there's no intersection between the tangent line and also the curve equation. So which means now I'm not going to solve the x, but I will just prove that no solution using discriminant method. So now the coefficient for x squared is 17, which is a, coefficient for x is minus 8, and then the coefficient, the constant is 2, which is a c is 2. So now my discriminant b squared minus 4ac. Now I will just calculate what is this value. That is minus 8 squared minus 4 times 17 times 2. So this is going to be 64 minus 136. And then you will be getting negative 72. This value is less than 0. So when less than 0 means that no real root. So in other words, no intersection. Okay, no solution for the intersection of these two curves. So then I will just say the curve does not have tangent which is parallel to the x-axis. Okay, so done for this question. Now next question, question number 7. Given the curve, the diagram shows the curve y equals to x exponential 2x minus 5x and its minimum point M, where x is alpha. A, show that alpha satisfies this equation. So your x equals to alpha, okay, this is when the x equals to alpha is the x coordinates of the minimum point. So a minimum point means we must get the turning point or stationary point, which means dy dx equals to 0. So now I will write y equals to x e 2x minus 5x. So again, this is the first term is the product rule. So now I will write my u equals to x, my v is e 2x. So my u prime is 1, my v prime is 2e 2x. Right? So now the product rule, d over dx uv, that is uv prime plus vu prime. That means now I'm going to get dy dx equals to uv prime. So x times 2e 2x plus vu prime, uv prime plus vu prime. So vu prime is basically e 2x times 1. Then now when you differentiate minus 5x, that is minus 5. And then now here I will rearrange. This is going to be 2x e 2x plus e 2x minus 5. And as I've mentioned just now, minimum points means dy dx equals to 0. So at M, x equals to alpha, dy dx equals to 0. Which means 0 equals to 2 alpha e 2 alpha plus e2 alpha minus 5. Now when you need to show this, okay, by looking at here, 1 plus 2 alpha, that means now here I have to group the e2 alpha. I will have to factorize the e2 alpha so that I will get 2 alpha plus 1. And then this minus 5 will be moved to the other side. Okay, then from here, I will write e2 alpha is basically 5 over, instead of writing 2 alpha plus 1, because I need to get 1 plus 2 alpha, so I just switch the two terms. So I have found these terms inside the bracket. Now in order to get ln, so you have to e both sides. So because we have a formula here, ln EA is A. Right? So now here I will just take ln E2 alpha equals to ln of 5 over 1 plus 2 alpha. Then the left hand side, it will be 2 alpha equals to ln of 5 over 1 plus 2 alpha, and at last the 2 will be moved down. So alpha will be half ln 5 over 1 plus 2 alpha. So with this, I have shown the given form. Okay, so next part B. Verify by calculation that alpha lies between 0.4 and 0.5. So to verify this, I'm going to use the sign change rule, which means now I get the equation of the f alpha first by moving this right side to the left side. Okay, so I will be getting alpha minus half ln of 5 over 1 plus 2 alpha equals to 0. Then I will just define the left side by f alpha. So let f alpha equals to alpha minus half ln 5 over 1 plus 2 alpha. And then replace the alpha by these two values. So f 0.4, it will be 0.4 minus half ln 5 over 1 plus 2 times 0.4. Then this is going to be negative 0.111, and it is less than 0. Now then, f 0.5, that is going to be 0.5 minus half ln 5 over 1 plus 2 times 0.5. Then you will be getting 0.0419. This is greater than 0. So now since one less than 0 and another one more than 0, then I will just write there is a sign change. So there is a sign change. Okay, so according to the sign change rule, that means hence alpha lies between 0.4 and 0.5. Okay, son. So done for part B. So C, use an iterative formula based on the equation in part A to determine alpha correct to 2 decimal places. Give the results of each iteration to 4 decimal places. So now refer back to the formula on or in part A. This is a formula, but in order to get the iterative formula, we need to add on the subscripts. So it means that for the left hand side, the alpha, I need to add on n plus 1, the subscript. Then the right hand side, whenever you have alpha, you change to alpha n. Okay. So now, and from the part B, we know that the alpha lies between 0.4 and 0.5. So for the initial alpha, you can let it be 0.4, 0.5, or any other values. So I will let it be the middle value, that is 0.45. Okay, with this, I can calculate my alpha 1. That is going to be half ln 5 over 1 plus 2 of 0.45. Then this is going to be 0.4838. That is my alpha 1. And then for my alpha 2, that is half ln 5 over 1 plus 2 times 0.4838 equals to 0.4663. Okay, now how do we decide when to stop this iteration? You need 2 decimal places. So you have to get exactly the same 2 decimal places. So means that now we need to continue because we are not getting the same decimal places. Okay, that means now here I got to find alpha 3. So my alpha 3 is half ln 5 over 1 plus 2 of 0.4663. Then this is going to be 0.4753. Again, I'm getting 0.47, just now 0.46. So continue for one more calculation to check. So this is alpha 4. Then it is going to be 0.4707. Okay, so now when you check the previous calculation 0.47, here 0.47. Alright, therefore my final answer, it depends on the latest calculation and the next value. So since next value is 0, therefore my alpha approximates to 0.47. So that is my estimated alpha value. Okay, question number 8. Express 3 sin x plus 2 square root 2 cos x plus 1/4 of pi in the form r sine x plus alpha, where r is greater than 0 and alpha is between 0 and half pi. States the exact value r and give alpha equal to 3 decimal places. Okay, so when you need to get r sine alpha x plus alpha, basically the general form is a sine x plus b cos x equals to r sine x plus alpha. Because if you sine, right, and the plus, it will be sine and plus. So then from here, I know that I get sine and cos. So I have to simplify my left hand side first before I calculate the r. Basically, after you have obtained this, my r is just square root of a squared plus b squared. Okay, then my alpha is inverse tangent b over a. So it means that now, first step, we need to simplify. So that you are getting first term with sine, second term with cos. Now, for the cos x plus pi over 4, I'm going to use cos a plus b formula. That is cos a cos b minus sine a sine b. Okay, this is the formula. Then now here, I will be getting 3 sine x plus 2 root 2 cos x cos pi over 4 minus sine x sine pi over 4. Okay, so this is same as 3 sine x plus 2 root 2. For your information, cos pi over 4 is 1 over root 2. So I will get 1 over root 2 cos x. Same goes to sine pi over 4. It is also 1 over root 2. So 1 over root 2 sine x. Okay, so now the root 2 can be cancelled off. So then these 2 will be multiplied to the brackets, right? So that means here it will be 3 sine x plus 2 cos x minus 2 sine x. So first and last term, when you simplify, that is sine x, then followed by plus 2 cos x. And now I'm going to express this sine x plus 2 cos x in r sine x plus alpha. Okay, so the coefficient for sine x is 1, right? This is 1. That means now my r is going to be square root of 1 squared plus 2 squared. That is square root 5. Then my alpha will be inverse tangent of 2 over 1. And this is in pi, okay? So leave your answer in radians. That is going to be 1.107. Right, 3 decimal places for the alpha value. So then, just rewrite 3 sine x plus 2 square root 2 cos x plus pi over 4 equals to, my r is square root 5. Then sine x plus the alpha is 1.107. So that is the solution of this question. Okay, now B, hence. Hence means use the previous answer, solve the equation. So here you get 6 sine half theta plus 4 root 2 cos. Hence means use the previous solution, means that now I will rewrite this first. Okay, 3 sine x. So from A, plus 2 root 2 cos x plus pi over 4. That is going to be root 5 sine x plus 1.107. This is from part A. Okay, now your question is 6 sine half theta. So if I compare first and second equations, so obviously the first equation I got times 2. Okay, so first equation I times 2. So it means that I will be getting 6 sine x plus 4 root 2 cos x plus pi over 4. So when times 2, it will be 2 square root 5. Then sine x plus 1.107. So the first equation becomes third equation. So now we are compare, okay, by comparing first and second. No, second and third equation. So obviously the x equals to half theta. Okay, so then here I will just write 3 equals to 2 square root 5 sine, replace the x in the third equation by half theta, plus 1.107. So now, basically we need to solve this equation. And now given that the theta is between minus 4 pi and 4 pi. So now here, right, I will get sine half theta plus 1.107, move down the 2 root 5. So it will be 3 over 2 root 5. Okay, then now I will write here minus 4 pi and 4 pi. That is my interval of theta. Okay, and then now I'm solving half theta plus 1.107 means that I have to times half. So when I times half, it will be 2 pi and negative 2 pi. And then plus 1.17. 1.107. That means now I will be getting 7.3902 as my highest value, and my lowest limit is negative 5.17. I give more decimal places, so negative 5.1762. That is my new interval, right? And now I will draw the quadrant. You see the sign is positive, that means it will be in first and second quadrant. So now my basic angle equals to inverse sine 3 over 2 root 5. This is going to be 0.7353. So I will label here these two values. But when you look at the interval over here, this is the interval, means that I can accept all these values, right? That means first angle is this, second angle, okay, and then the third angle, because 2 pi plus, just now here plus, so I will say third angle. Okay, after that you consider the negative value. So the negative value will be the green color. This is a negative value. Okay, so you cannot consider negative value up to up to here, because it is greater than, it is outside the range. Okay, I will say outside the range. So from here I will say half theta plus 1.107 is basically 0.7353 as a first angle, and then it will be pi minus 0.7353. That is my second angle. And then my third angle is the greatest angle. That means it's 2 pi plus 0.7353. Then the next angle is the green color. That is negative of pi plus 0.7353. And then from here, I will be getting this value. Excuse me. The next value is 2.4063. And then (7.0185). Excuse me. followed by negative 3.8769. Okay, so for all of these values, the next step is move the 1.107 to the left side. So that means you have to minus all the values from from 1.107. So I will be getting half theta equals to negative 0.3717, and then 1.2993, 5.9114, and then negative 4.9839. And now to get the theta times 2 to the whole equation, right, to all the values, so you will get negative 0.7434, 2.5986, 11.8230, and then negative 9.9678. So our answer will be correct to three significant figures. That is negative 0.743, 2.60, 11.8, and negative 9.97. So these are the solutions of the data. Okay, next question number 9. Relative to the origin O, the position vectors of 3 points ABC are given. So A show that OABC is a rectangle. Okay, let's say this is a rectangle. This is a diagram. OABC. Now, first of all, I need to show that AB is parallel to OC. Then OA is parallel to CB. So I find AB first. Vector AB is OB minus OA. That is going to be 8, 2 minus 6 minus the OA 5 minus 2, 1. Then this is going to be 3, 4 minus 7. Okay, so I compare AB with OC. So OC is 3i, so 3, 4j, and minus 7k. That means from here I know that AB, vector AB is same as vector OC, exactly the same. And now I need to prove OA and CB. So I find the CB first. CB is OB, vector OB minus vector OC. So this vector OB is 8, 2 minus 6. Minus OC 3, 4 minus 7. So this is going to be 5 minus 2, 1. Okay, then I will compare this with OA. Vector OA, and in the question it is 5 minus 2, 1. So obviously, vector CB is same as vector OA. Okay, so now I will calculate the length of AB. So length of AB, you can just write square root of 3 squared plus 4 squared plus minus 7 squared. This is square root 74. Okay, magnitude of CB. So CB is same as OA. You just calculate this this magnitude. Square root of 5 squared plus minus 2 squared plus 1 squared. So that is going to be square root 30. Now I can conclude that AB and OC are the same length with how much, and then CB and OA with how much length. Okay, so AB equals to OC and CB equals to OA. Implies that AB is parallel to OC So now the AB with the arrow means that that is the length, okay? With length on the side, square root 74 units. And CB is parallel to OA. With length, square root 30. Okay, same length. But then this same length, now we know that they are parallel and with the lengths, right? So we need to show that it is rectangle. Rectangle means that it must be perpendicular to each other. So now I need to use the properties of the scalar product, right? So whenever two vectors perpendicular to each other means that their scalar product is equal to 0. So I'm going to show OC dot OA, right? Or OA dot OC. So OA is 5 minus 2 dot OC 3, 4 minus 7. So for the dots product, you just multiply. Okay, just multiply. Then you will be getting 5 times 3 plus minus 2 times 4 plus 1 times minus 7. So this is going to be 15 minus 8 minus 7. Obviously is 0. So OA is perpendicular to OB. OC, because the dots product of OA and OC. Okay, so if OA is perpendicular to OC, that means OA is also perpendicular to AB, right? Because we have proven just now the length will be the same. So then, and also perpendicular, and also parallel to each other. So implies that AB is also perpendicular to CB. Therefore, the 4 points form a rectangle. Okay, so this is how we show that the 4 points form a rectangle. Okay, now B. Use the scalar products to find the acute angle between the diagonals of OABC. So use back the rectangle OABC. Now the diagonals. And this is the acute angle. Okay, or maybe here. Right? So from here, I will say that this is the angle, or probably this is the angle. Right? So since this is a diagram, we can just simply label first. Now, from here, according to the scalar product formula, we need two upwards vectors. So here B, A and B, right? That means now I will refer to AC and OB. Okay, so no need to find the middle point. So I will just write let theta be the angle between AC and OB. So now we need to find out the vector AC. Okay, vector AC is not given or is not available in previous part. So vector AC is basically OC minus OA. So now here, vector OC is 3, 4 minus 7. Minus OA. So the OA is 5 minus 2, 1. then you will be getting minus 2, 6, minus 8. And now I need to find AB. AB is given. Just need to rewrite. So OB, sorry, OB. OB is 8, 2 minus 6. Okay, so now use a scalar products formula. Scalar products formula is basically like this. This is A, this is B, here is theta. So A dot B vector equals to vector A, magnitude B cos theta. So now I'm using the vectors OB here, OB and AC. So AC dot OB equals to magnitude AC, magnitude OB cos theta. So for the dots product, basically you just times the component, right? So it will be negative 2 times 8 plus 6 times 2 plus minus 8 times minus 6. That will be the dots product, square root. The magnitude AC is square root of minus 2 square plus 6 square plus minus 8 squared. Then the other magnitude is 8 square plus 2 square plus minus 6 squared. Then after that cos theta. So for the left hand side, we get the total. That is going to be 44. So for the first square root, it will be square root 104. And the second square root also same value, square root 104. Then cos theta. So now to get the angle, make sure it is acute. Acute means it's between 0 and 90 degrees. So now I will say cos theta equals to 44 over this square root 104 times square root 104 move down, it will be 104. So now my theta is going to be inverse cos of this value. Then this is going to be 64.97 degrees and 97 degrees. Then now round up to one decimal place. Okay, look at the 7. So 7 is more than 5, therefore round up. So when you round up the 9, it becomes 65.0 degrees. So that is your solution of the acute angle. Okay, next question, number 10. Given fx, express fx in partial fractions. Okay, so now first of all, when you look at the numerator, there is no x. Okay, and the denominator, when you do expansion, you will get x cubed. That means this is proper rational function. So we can just direct find the partial fractions. So then I will get 36a squared over 2a plus x, 2a minus x, multiplied with 5a minus 2x. Then now, since the denominators are all linear factors, so I will just write a over first linear factor plus b over second linear factor plus c over the third linear factor. Okay, so now get the same denominators. Means that here I will get a over 2a plus x multiplied with the other two terms. Okay, basically you can just get the same denominators. So for the b, you are given the middle factor now, so you multiply with the first and third factor. Okay, same goes to the c. I need to multiply with first two factors. Okay, so with this, you will be getting all the same denominators. So then I will just ignore the denominators and write down the numerators. So I will be getting 36a squared equals to a times 2a minus x. Just write down all the numerators. Plus b times by 2a plus x. Then 5a minus 2x. Plus c times with 2a plus x. Then 2a minus x. Okay, so our purpose is to get the capital letters A, B, C. So now, to get these three letters, these three unknowns, I can just let the factor be 0. First of all, I will let 2a minus x be 0 to find out my x value. So my x is 2a. Then I will replace this x in the previous step. That means here I will be getting 36a squared. So whenever you see 2a minus x, this will be 0. And the last term will be 0. So I can find the b directly. So it means that now I will write equals to b bracket, my x is 2a. So 2a plus 2a, that will be 4a. And then 5a minus 2x, my x is 2a. Therefore, that is 5a minus 4a, that is a. Okay, so from here, basically 36a squared is 4a squared b. That means my b is going to be 9. Now, next is let 5a minus 2x be 0. Okay, that means my x is going to be 5 over 2a. So now 36a squared. So whenever you see this 5a minus 2x, that will be 0. So it means that I can find the c directly. So it means that now I will be getting equals to c bracket 2a plus 5 over 2a. Okay, then 2a minus 5 over 2a. And here you will be getting 36a squared equals to 9 over 2a multiplied with negative half a. So this is going to be 36a squared equals to negative 9 over 4a squared c. So then the c is, so the a squared will be cancelled off from both sides. Then c is 36 times negative 4 over 9. Then you will be getting negative 16. Okay, lastly, you let this 2a plus x be 0. That means my x is negative 2a. So obviously I'm going to find the a now, the capital letter A. 36a squared equals to capital letter A. So 2a minus, so it will be 4a. 5a minus 2 bracket 2a, that means this is 9a. Okay, so 36a squared equals to 36a squared a. Therefore, the capital letter A is 1. So now I will just rewrite. So 36a squared over the 3 factors. That is going to be, okay, a over 2a plus x. So a is 1. 1 over 2a plus x. Then b over 2a minus x. My b is 9. Okay, so plus 9. Then my c is minus 16. So minus 16 over 5a minus 2x. So these are the partial fractions. Okay, B, hence find the exact value of this integration. Leave your answer in P ln Q plus R ln X, where P and Q are integers, Q and S are prime numbers. So integrate from minus a to a fx dx. That is to integrate from minus a to a all the partial fractions. Just copy all these three terms. So I will write 1 over two a plus x plus 9 over 2a minus x minus 16 over 5a minus 2x dx. Okay, so for this case, right, when we differentiate, now when you integrate, I would say integrate fx, and then the numerator is f prime x. This is going to be ln fx plus c. So when I differentiate plus x, I get 1. Okay, which means now here I will rewrite, I split it into 3 integrations. So when I differentiate minus x, I should get minus 1. So here I will write plus integrate the 9 taken out over 2a minus x dx. It should be minus 1 here. So you times another minus 1 because it was plus. So let me write. Then from minus a to a. And then the last one, where I differentiate minus 2x, I will get minus 2. So I will write plus minus 16 integrate 5a minus 2x dx. Here should be minus 2. Then here you have to divide by minus 2. Okay? So now this is going to be ln of 2a plus x. If you are sure that it is positive, then you no need to write the modulus. Okay, you don't need to write the modulus. Now, for the next one, this is minus 9. Okay, then the last one, this is plus 8. So the rest of the integration just change to ln. So I will write minus 9 ln 2a minus x, then plus, this is minus a to a, plus 8 ln 5a minus 2x with limits. Then from here, just replace the values. Let x be a. So you will get ln 3a minus 9 ln a plus 8 ln 3a. Because all the terms inside the after the ln are positive, so I will just ignore the modulus. Then minus when the x is replaced by minus a. Okay, so then here the first term will be ln 2a minus a is 1a, and then minus 9 ln a ln 3a. Okay, because 2a minus minus, that is 3a. Then plus 8 ln 7a. Then now leave your answer in the simplest form. That means here I will be getting, okay, I will rewrite first. So this is going to be, okay, open the brackets first. Ln 3a minus 9 ln a plus 8 ln 3a minus ln a plus, bring in the minus, plus 9 ln 3a minus 8 ln 7a. Okay, then here, now for the, here 3a, 3a, 3a. Okay, so here you get 9 plus 9, 18. So 18 ln 3a. And then minus 9 ln a minus 1 ln a. That is minus 10 ln a. After that, last term, minus 8 ln 7a. Okay, then look at the question. It should be P ln Q plus R ln X ln S. Q and S are prime numbers. Okay, so now I have to split into 2. Therefore, here I will write 18 ln 3 plus 18 ln A, because we have this identity, ln A, B, that is ln A plus ln B. Okay, so the ln 3A I change to ln 3 plus ln A. Then minus 10 ln A minus 8 ln 7 plus ln A. Therefore, this is going to be 18 ln 3 plus 18 ln A minus 10 ln A minus 8 ln 7 minus 8 ln A. Then from here, just simplify. Ln 3 here, okay, ln 3. So I get one term, 18 ln 3. Now, 18 ln A minus 8 here. Okay, so 18 minus 10 minus 8. That means these 3 terms will be cancelled off. So I will get another term that is negative 8 ln 7. So 3 and 7 are prime numbers. Okay, according to the question here. Alright, so done for this question. Let's move on to the next question. So next question 11, the variables y and theta satisfy the differential equation. Is given y equals to 0 when theta equals to 1 over 4 pi. Solve the differential equation and find the exact value of theta when y equals to 1. So this is the first and second. Now 1 plus y multiplied with 1 plus cos 2 theta dy over d theta is e3y. Now to solve this, I will use separable variables. Means that you look at here, dy is the numerator, so all the y should be on the left side, which means I will move this exponential to the left side and the theta, the 1 plus cos 2 theta together with the d theta to the right side. So I will be getting 1 plus y. When you move the exponential to left side, it becomes e power negative 3y. Then dy, right side will be 1 over 1 plus cos 2 theta d theta, and integrate both sides at the same time. Now, for your information, the left-hand side you need to solve using the integration by parts. Okay, so now integration by parts, that is integrate uv prime dx equals to uv minus integrate v du dx u prime dx. So now for the left hand side, my u equals to 1 plus y. Then my u prime is 1. My v prime is exponential negative 3y. So then my v, when you integrate exponential, you rewrite and divide by the power of e. Okay, now for the right hand side, I need to simplify using the double angle formula, which is cos 2a equals to, because you have 1 plus, so 1 minus 2 sine squared a, or you can choose 2 cos squared a minus 1. But then we need 1 plus, so it means that 1 plus, I have to choose the second form. So that this minus 1 move to the other side becomes 1 plus. So which means now here I will be getting cos 2a, 1 plus cos 2a, that is 2 cos square a. Okay, so when you compare, means that your a is theta. Right, so now for the left hand side, by applying this by parts formula, that is going to be 1 plus y times exponential negative 3y over negative 3 minus integrate e negative 3y over negative 3 times 1 dy. Then the right hand side, 1 plus cos 2 theta, that is 2 cos squared a, 2 cos squared theta. So integrate 1 over 2 cos squared theta. Okay, so For the left hand side, you just further simplify. That is going to be, since the e with negative degree, I can just move it down. So combine with the negative 3. So I will just write negative outside. Then 1 plus y over 3e, 3y. So minus minus is a plus, right? Take out this minus 3. So 1 over 3. And again, when you integrate exponential, negative 3y, just copy. This is the result. So I will write e negative 3y over negative 3. Then right hand side, that is half, integrate 1 over cos is basically second. So I will change to second squared. Excuse me. Then this is going to be rewriting the left hand side. Okay, or the 3y, the exponential can be moved down. Integrate second squared theta is basically tangent theta, and plus c. Okay, after this, replace the y and theta value. So y0, theta is 1 over 4 pi. y0, theta is pi over 4. Then here I will be getting negative. So y is 0, means 1 over 3e 0 minus 1 over 9e0 equals to half tangent pi over 4, then plus c. So e0 is 1. That means negative 1 over 3 minus 1 over 9 is half. Tangent pi over 4 is 1. Okay, this is 1. Here is also 1. Then plus c. That means now your c is going to be negative 17 over 18. So once we have found the c, just substitute back into this expression. So which means negative 1 plus y over 3e 3y minus 1 over 9e 3y equals to half tangent theta minus 17 over 18. So this is the solution for the differential equation. Okay, now next part is find the exact value of tangent theta when y equals to 1. So when y equals to 1, right? So replace first. I will get, now according to the question, you need to find tangent theta. Okay, so I will get the tangent theta as the subject. So it means that this negative 17 over 18 will be moved to the other side. So I will get half tangent theta equals to negative, replace the y by 1, so get 2 over 3e cubed, then minus 1 over 9e cubed minus, or the minus change to plus 17 over 18. So the first two terms, minus 2 over 3 minus 1 over 9, that is minus 7 over 9. So I will write minus 7 over 9e cubed, then plus 17 over 18. And now you times 2. So tangent theta is going to be negative 14 over 9e cubed and plus 17 over 9. So the question is asking for exact value of tangent theta, which means I have solved the question. Okay, so with this we have done this question. Right? And I have completed the whole paper. It also comes to the end of the video. Thanks for watching. If you enjoy watching my video, please like this video and share this channel with your friends. And also stay tuned for more upcoming videos. Thank you everyone. Bye.